A silence older than memory travelled with the object long before anyone knew it existed. It moved through interstellar darkness without resistance, without origin that human science could yet describe, gliding through a region of the cosmos where matter is so sparse that collisions are almost mythological. There were no embers of a dying star behind it, no cloud of gas to betray its birthplace, no familiar gravitational influence shaping its path. What eventually entered the solar system was a visitor defined not by dramatic arrival, but by the quiet precision of inevitability, as if it had always been travelling toward this moment. Long before the first telescope recorded the faint reflection of sunlight against its structure, before astronomers began debating its impossible course, before measurements ruptured the scientific status quo, the object was already here, already threading itself into the geometry of planetary orbits and ancient radiation. Nothing about its approach resembled the behaviour of comets known to originate in the distant reservoirs of the Oort cloud. Typical comets slow as they enter the gravitational field of the Sun, adjusted by the sculpting hand of orbital mechanics. This one did not. It retained a velocity too high for capture and too structured for randomness. It slipped across the heliospheric boundary like a blade through still water and did not flinch. The deep infrared sensors that later reconstructed its arrival would show no flare of dust, no outgassing signature, no thermal bloom to mark a chemical interaction with solar wind. It appeared to be conserving itself, conserving heat, conserving mass, conserving orientation. The trailing particles that should accompany an interstellar traveller did not exist. Space dust that should cling to an object after millions of years of flight was missing entirely. An untouched surface confronted the instruments that later mapped it as if the object had not interacted with anything during its passage between stars. The darkness around it was pristine, not scored by the turbulence normally seen when a comet crosses magnetic boundaries or interstellar shock fronts. It behaved less like a body wandering through the cosmos and more like something that had followed a route mapped with intention. The first gravitational influence it encountered inside the solar system produced an effect that even after months of analysis did not align with any known celestial model. Instead of decelerating in response to solar pull, the object preserved momentum with uncanny precision, like a dancer guided by a choreography no surrounding body could alter. Its motion was not defiance of physics, but the expression of physics tuned to parameters no one had yet decoded. Astrodynamic simulations would later reveal that the trajectory was so fine-tuned that a deviation of a few kilometers across millions of miles would have hurled it entirely out of the planetary plane. Yet the object followed the orbital paths of the inner world perfectly, not out of gravitational bonding, but through passing alignment like a shadow tracing the outline of celestial architecture. If this path were coincidence, it was a coincidence so statistically improbable that even the most conservative analysts hesitated before calling it chance. Some of the earliest data captured from automated observatories contained a faint but measurable detail that would not be fully understood until weeks later. The light that reflected from its structure seemed to respond differently, depending on which portion of the electromagnetic spectrum touched it. To ordinary telescopes, it presented a cold, inert surface. To ultraviolet, it responded with a softness that resembled absorption more than reflection. To deep infrared, it behaved as if it were warmer inside than outside, holding thermal energy as though it were insulated. These contradictory profiles should have flagged an anomaly instantly, but the object was so faint, so distant, and so unexpected that no one was initially prepared to interpret its nature. At the moment of arrival, it was nothing more than a smudge in the mosaic of stars, a misbehaving dot of faint luminosity that did not yet carry meaning. The first automated catalogue of the season recorded it, and moved on unaware that history was being archived in a simple timestamp. The data sat unnoticed in storage drives, while the object continued inward, crossing the outer solar system with steady indifference. Planets unaware of their role in the unfolding mystery continued their orbits at familiar speeds. Saturn's rings shimmered, Jupiter's storms raged, Neptune drifted through its endless winter. In this vast mechanical clockwork of gravity and gas, the object was not sensed by any biological observer. There was no discovery yet, no theory, no alarm, no anticipation of the chaos that would follow. The universe demonstrated once again that the most transformative events often begin in silence. The precision of the object's path suggested a memory of momentum, a record of origin carved into velocity and angle. It was not wandering, it was not lost. It was travelling along a course that somewhere somehow had been determined long before human eyes ever considered the idea of interstellar visitors. After millions of years of flight, it crossed the final dark stretch between interstellar space and the sun's dominion, like something returning rather than arriving. For a moment before detection, before numbers and theories and fear, there was only the quiet truth that something not born of this system was now within it. Nothing conscious witnessed its entrance, yet the solar system itself reacted. The plasma flow of the heliosphere bent and reshaped around the object, with a subtlety that would later be visible only in ultra-sensitive datasets. The scattering of charged particles hinted at a disturbance in local fields faint and nearly indistinguishable from noise. Unaware humanity slept beneath atmospheric comfort, not knowing that something alien to every model of planetary motion had already joined the cosmic stage. Soon the first reflection of sunlight would be captured by a telescope. Soon the automated warning systems would flag an unexplained trajectory. Soon the term interstellar object would reappear in scientific discourse with renewed urgency. Yet here in the earliest moment, the story of 3i Atlas was simply a story of arrival of a quiet object, following a path mapped in silence, carrying with it questions that would unsettle astronomy cosmology, and every assumption about how the universe stores its memories. No one yet suspected that this arrival would lead to discoveries that challenged the fundamentals of relativity, entropy, and quantum fields. It began calmly, without spectacle, without threat. The silence was the first anomaly. The first detection was not a dramatic moment broadcast across the world, but a silent notification inside a control room, a data flag triggered by software designed to watch the sky without emotion. Astronomers had been conducting a routine survey, charting transient objects, mapping known asteroids, and refining orbital paths for familiar comets, when a faint signature emerged on the mosaic. It was almost indistinguishable from noise, a dim fragment of reflected light that registered for a fraction of a second before disappearing into background interference. The automated system tagged it for follow-up, not because it seemed important, but because it seemed inconsistent. Objects of that luminosity and distance should follow predictable arcs defined by gravitational pull and rotational geometry. Yet the angle of motion captured in that single frame implied a velocity few had seen before. At first, the possibility of an instrumentation error seemed far more reasonable than the existence of a previously unseen interstellar visitor. Telescope sensors often respond to temperature fluctuations, electromagnetic interference, and light scattering in unpredictable ways. A single miscalibrated pixel can mimic an object. That was the assumption technicians held as they reviewed the footage. If the dot returned in the next imaging cycle, the anomaly would require attention. If it did not, it would go the way of thousands of other false positives erased quietly from the catalogue of the night sky. Hours later, the same signature appeared again. This time the signal was marginally brighter, not because the object emitted more light, but because it was closer. The phase angle of reflection matched the path of a distant body moving with tremendous speed toward the inner solar system. The program cross-referenced the data with known catalogues of comets and asteroids. No match appeared. It compared the trajectory against orbital families, the long-period wanderers that arc through the Oort cloud and return in thousands of years. Again, no correlation surfaced. What unsettled the team in the observatory was not the presence of something new, but the lack of any physical category into which it could be placed. The confirmation of motion ignited an instinct sharpened by decades of discovery. Astronomers began requesting time on additional telescopes. Observatories in different continents performed synchronous imaging to eliminate the possibility of artifact or atmospheric distortion. One by one, confirmations returned. The object was real. It was travelling inward. It was not slowing. It was not bound by the gravitational arc expected of a solar system body. Every detail gathered strengthened a truth no one wanted to announce prematurely. The trajectory was hyperbolic. History had trained astronomers to treat such claims with caution. Most objects that initially appear to come from interstellar space are later shown to be distant members of our own system, perturbed by gravitational influences or rejected by planetary interactions. But those explanations require a sort of orbital memory, a path that reflects the structure of the solar system. The newcomer did not behave like something that formed here, nor like something expelled from here. Its angle of approach was too steep, too direct, too liberated from the flat plane shaped by the sun's early birth disk. It came from above and beyond that ancient layer, from a direction with no known reservoir of objects. The internal debate was cautious rather than exuberant. Every time an astronomer believed they had ruled out a conventional explanation, they searched for another. The notion of declaring a third interstellar object so soon after the scientific revolution that followed Oumuamua and Tuai Borisov carried both excitement and unease. Some hoped for an answer that aligned with existing physics. Others quietly wondered if this discovery would mirror the sense of confusion and controversy that followed the first. The idea that something not born of this solar system was approaching again so soon felt statistically improbable. Yet the mathematics refused to soften. As the data grew, so did the list of oddities. The object displayed no coma, no haze of sublimating ice, nothing resembling the thermal response that would be expected as it came into contact with solar radiation. If it contained volatile compounds, they were not reacting. If it contained ice, it did not sublimate. Even asteroids warm fracture, radiate and scatter dust as they approach the sun. This object did not. Scientists were trained to understand variation within nature, but variation has boundaries. The newcomer remained stubbornly outside the boundaries. Eventually, the Minor Planet Center issued its first official designation and confirmed what many had been hesitant to say aloud. The object was not gravitationally bound to the Sun. Its hyperbolic trajectory was undeniable. It received the name 3I Atlas, marking it as the third confirmed interstellar object in human history. No major announcement followed at first. Observatories began coordinated surveillance before the global media could transform the discovery into speculation. What mattered was collecting as much data as possible, while the object remained close enough to measure. A request for emergency telescope time across multiple facilities was approved with unusual speed, a sign of how seriously the scientific community viewed the event. Radio observatories joined the effort. Infrared satellites were pointed toward the faint traveller. Even particle monitors that typically focused on solar wind fluctuations began logging data just in case interactions at the heliospheric boundary had left a measurable imprint. The object that began as a single misplaced pixel in the darkness was now the focus of a coordinated global inquiry. In those early days of detection, no one spoke of the chaos that would later unfold. The scientific community was driven not by fear but by curiosity, the same timeless instinct that once compelled humans to map coastlines and catalogue distant stars. Yet there was an undercurrent of tension that seasoned researchers felt but rarely admitted. Nature does not often repeat something extraordinary without reason, and the arrival of a second and now third interstellar visitor within such a short span whispered of patterns not yet understood. If the universe was sending fragments from beyond its familiar borders, then those fragments must have stories to tell. Whether those stories concerned life-destruction entropy or cosmic memory remained unknown. For now, there was only the discovery a moment suspended between excitement and foreboding. Telescopes stared at the object not as an intruder, but as a messenger. What it carried no one yet knew. In the hours that followed the official confirmation of the object's path, the calculation that changed everything arrived quietly. A small team analysing the orbital curve submitted a report indicating that 3I Atlas was not simply on a hyperbolic trajectory, but on one so steep that it effectively excluded every known method of formation within the solar system. Even the most energetic gravitational slingshot scenarios could not produce such a course without destroying the object itself. There was no mathematically consistent way to reverse engineer the path back to a perihelion inside the Sun's domain. Instead, the curve traced backward to a region in interstellar space, where no detectable stellar system existed. If the numbers were correct, 3I Atlas had not merely come from outside the solar system, it had come from a direction with no obvious point of origin. Cometary dynamics are normally lessons in predictability. A body forms in the Sun's gravitational nursery, drifts outward, and eventually returns under the same forces that shaped it. This was the basis of celestial mechanics since Kepler and Newton. Yet when it came to 3I Atlas, none of those frameworks applied cleanly. The velocity was wrong, the angle was wrong, and the conserved momentum suggested a history radically different from that of long-period comets. Orbital models showed that if the object had started anywhere inside the Sun's gravitational influence, its path would require repeated violent gravitational interactions that would strip mass, alter orientation, and destabilize rotation. The newcomer showed no scars of such a past. Its trajectory was not the fractured journey of a body pushed and pulled by planets. It was a straight passage from elsewhere. The more the data circulated, the more disquiet settled over those who knew how to read the numbers. The object was simply not behaving the way an unbound fragment of matter should. Most interstellar objects, if they exist in large numbers, would presumably travel with chaotic variation, having been scattered by stellar nurseries, supernova shockwaves, or the disruption of young planetary systems. They would be motes on the cosmic wind drifting without pattern. But 3 Atlas demonstrated an extraordinary coherence of motion. It maintained a consistent orientation over vast distances, conserving angular momentum with an elegance that even the most symmetrical comets do not display. The first scientific papers published in preprint servers reflected a tone of caution rather than alarm. They noted the improbability of the trajectory, compared it with known interstellar objects, and calculated the likelihood of observing 3 such visitors in such a short interval. That probability was vanishingly small, unless the universe was far richer in wandering fragments than previously believed. A few authors argued that the solar system might exist in a region where interstellar bodies are more common than models predict. Others proposed that deeper surveys would likely uncover many more of these visitors once technology improved. But even those explanations did not satisfy the problem of directionality. Random arrival should disperse arrival vectors uniformly. Instead, 3I Atlas came from a region suspiciously close to the approach corridor of the first interstellar object 1I Oumuamua, though the angles did not align precisely enough to form a pattern that could be safely announced. The attempt to resolve the object's velocity deepened the unease. Even after accounting for solar acceleration, the inbound speed remained too high to be consistent with natural drift through galactic space. To achieve such a velocity, an object would likely have been subjected to extreme forces such as gravitational flinging from a collapsing star or the shock front of a supernova. Even then, directional coherence would normally collapse as the object encountered dust and gas along its journey. Rather than slowing over time, 3I Atlas seemed to have preserved speed like something insulated from contact with matter. Across the major observatories involved, scientists began expressing the same sentiment, phrased in different languages, different tones, and different degrees of restraint. The orbit should not exist. The trajectory was not physically impossible, but it required extraordinary circumstance or extraordinary history. Without knowing what sculpted the motion, the object posed a conceptual challenge as much as an observational one. Another detail contributed to the growing mystery. The rotational period of 3I Atlas was measured using reflected light curves from multiple facilities. Instead of the irregular tumbling expected from an interstellar object battered by eons of cosmic forces, the rotation was calm, rhythmic, and consistent. The surface reflected sunlight with a timing that indicated a stable spin axis and balanced mass distribution. No major asymmetry appeared, no chaotic wobble. If the object had been hit repeatedly across its lifetime in space, its spin would be unstable. Instead, the spin resembled something that had never suffered a catastrophic impact. Small teams began working around the clock to reprocess data, searching for subtle inconsistencies that might resolve the dilemma. If the trajectory could be explained by conventional physics, the mystery would dissolve into a rare but natural phenomenon. Yet every new refinement of the orbit reinforced its strangeness. It did not curve to meet the sun. It did not bow under gravitational persuasion. It passed through the solar system like an idea refusing correction. Observers anticipated that the strangeness would resolve as the object approached the region where solar radiation intensifies and where gravity shapes every traveller with brutal efficiency. A hyperbolic path is hard to dispute near the sun. The mathematics becomes undeniable, the curve stabilizes, and the trajectory achieves final definition. If the object belonged to the solar system, after all, its orbit would transition from hyperbolic to elliptical as it fell deeper into gravitational dominion. When those calculations were finally completed, they confirmed the one conclusion everyone hoped would not be true. The orbit was hyperbolic with no possibility of capture. 3I Atlas would never return. It did not belong here. It had entered from an unknown place and would leave toward another unknown place. For the scientific community, the excitement of discovery was now joined by something more complex than fear, more cautious than awe. An object that should not exist was among the planets. It had followed a path that defied the most familiar cosmic rules. The solar system had received a visitor from a region that the universe had kept quiet until now. The question that emerged repeatedly in the quiet corridors of research centers was not merely how it arrived, but why. Long before the public began to hear whispers of an interstellar visitor, laboratories and observatories were already struggling to interpret a set of measurements that did not fit comfortably inside the boundaries of known comet chemistry. Spectroscopy was the first tool brought to bear on the mystery, passing the faint reflected light from 3I Atlas into a chemical fingerprint. What emerged from the early spectrographs startled even the seasoned researchers who had spent careers decoding the molecular stories of distant bodies. Conventional astrophysics once assumed that the building blocks of comets were largely universal, shaped by similar conditions across stellar nurseries at different points in the galaxy. The more the spectrum of 3I Atlas was examined, the more it shredded that assumption. The ratios of carbon chain molecules and metallic compounds were unlike anything produced near the Sun or in any stellar nursery that shared the chemical lineage of our system. As more wavelengths were sampled, new irregularities surfaced. Oxygen isotopes did not align with the signatures familiar from solar system ice. Trace nickel and iron were present in amounts that did not match the thermal histories typical of primordial bodies. The crystalline profile of silicates suggested formation under pressures and temperatures far beyond those normally encountered during planetary birth. If the object had been raised in the same environment as the comets we have catalogued for centuries, its fingerprint would have been recognizable. Instead, it declared itself to be something shaped by a forge unknown to this region of space. While researchers avoided drawing premature conclusions, the implication was unmistakable. The object had formed around a star that was not our own. The first complete chemical model was shared privately among a small network of researchers, and the reaction was nearly unanimous disbelief. Some physicists questioned the calibration of the spectrographs. Others reprocessed raw data to look for contamination or atmospheric interference. In most cases, when scientific results appear implausible, it is because there is an error buried somewhere inside the methods. Yet every attempt to correct the anomaly only reinforced it. The chemical profile of 3I Atlas refused to bend toward normality. It was as though the object had been shaped by a cosmic recipe that did not exist anywhere near the environment that formed our planets. A detail buried deep inside the observation logs revealed something more unnerving. The water ice signature, normally one of the clearest identifiers in cometary chemistry, exhibited a ratio of hydrogen isotopes that did not correspond to known galactic trends. The liquid-solid transitions that shape molecular arrangement within ice demand very specific thermal histories. If a comet forms near a star with a particular metallicity, its water records that history. The water of 3I Atlas did not correspond to any of the known environments in nearby star systems. It was not a twin of solar system ice, nor was it consistent with the profiles observed in interstellar clouds studied across the Milky Way. The only honest conclusion left was the most difficult one. The object bore the molecular accents of a birthplace unlike any yet documented. Still, the researchers resisted sensational interpretations. Rather than concluding that the object came from a distant or exotic region, some suggested that the distribution of isotopes across the galaxy might be more varied than previously understood. If the Milky Way hosted chemical neighborhoods that had not yet been sampled, then 3I Atlas might simply be our first messenger from such a region. But rejecting speculation did not make the oddities vanish. Every new reading reinforced the same pattern. The object carried a chemistry that was not a cousin to ours but a stranger. The implications of this chemical distance were profound. If cometary bodies across the galaxy vary more dramatically than expected, then the early conditions that give rise to planets' atmospheres and perhaps biology itself might be more diverse than standard models propose. Even before the drama of later discoveries, 3I Atlas silently challenged the assumption that the universe builds worlds from a single blueprint. With every spectral scan, the possibility emerged that life, if it exists beyond Earth, might originate from physical environments that bear little resemblance to the one that shaped our biosphere. The infrared observatories contributed another layer of complexity. Their sensors detected a thermal behavior that contradicted expectations. Most icy bodies heat unevenly, causing localized outgassing and dust release as they approach a star. This activity generates a coma, the familiar trailing haze of a comet. 3I Atlas resisted that transformation. It absorbed heat without shedding materials. It behaved as if it were insulated against the most fundamental process that defines a comet. The surface temperature rose, but the loss of mass remained negligible. Even those who approached the phenomenon conservatively could not ignore the implication. Either the structure of the comet was reinforced in ways not seen before, or it was composed of a substance capable of retaining volatile compounds under conditions that normally tear them apart. As spectroscopic imaging improved, faint ultraviolet resonance revealed compounds that formed under pressures expected near dying or unstable stars. If the object indeed came from such an environment, its chemical memory told a story of destruction, not emergence. It was not the fragment of a growing world, but possibly the remnant of one that collapsed. The early images did not show the beauty of a pristine object. They showed the stoic durability of something that had survived violence on a scale difficult to imagine. Even without dramatic visual displays or unusual radiation, 3I Atlas communicated one truth clearly through chemistry alone. The object had been shaped somewhere alien to us, somewhere with physics familiar enough to rhyme with our understanding of matter, yet different enough to unsettle the foundations of that understanding. It carried a molecular biography that did not match the rhythm of this solar system, nor the family of bodies orbiting nearby stars. It was a traveller from a chapter of cosmic history humankind had never read. For the researchers who first interpreted the chemical profile of 3I Atlas, the question was no longer simply what the object was. A deeper question took shape quietly but decisively. What kind of environment had forged a body so unlike anything the solar system had ever seen? The mystery was no longer mathematical, it was material, and matter does not lie. Even before the chemistry was fully mapped, another event drew the attention of the scientific community with a force impossible to ignore. The inbound object began to accelerate. It did not surge dramatically, did not ignite, did not produce a trail of gas or plasma that would justify an increase in speed. The change was subtle, barely measurable at first, but unmistakable. Instruments that monitored the object's progress reported a shift in velocity that should not have been possible for a body of that size and composition. Nothing in classical celestial mechanics permits a frozen object to gain speed without a force acting upon it. Solar radiation, gravitational pull, and thermal outgassing all produce recognizable patterns of acceleration, and none of those patterns matched what was unfolding. There was no coma forming to generate reaction force. No mass loss could be detected. The rise in temperature did not translate into expelled particles. Yet the acceleration continued as though the comet were responding to something beyond the reach of current measurement. For decades, textbooks presented the idea that comets accelerate only when they sublimate, under stellar heat releasing volatile gases that push them forward. The behavior of 3I Atlas refused to conform to that principle. It acquired speed while remaining intact, sealed and eerily quiet. Once the acceleration had been confirmed independently by multiple observatories, the tone of the conversation changed. This was no longer an anomaly hidden in data sets. It was a violation of expectation unfolding in real time, visible to every observatory that cared to measure it. The acceleration persisted with a precision that was even more disturbing. Instead of varying with temperature distance or solar exposure, the gain in velocity followed a smooth curve that no physical variable could explain. It was as if the object were responding to a command rather than to nature. The debate shifted rapidly from error checking to interpretation. Some researchers argued that the object might be shedding mass in ways invisible to spectroscopy. Others proposed exotic structural compositions, hypothesizing elements that sublimate without producing detectable emissions. But even as those ideas were evaluated, the timeline of acceleration failed to match the theoretical curves. The velocity increase did not correlate with the energy the object received from the sun. It followed its own schedule as though it had a memory of where it intended to go and was adjusting course accordingly. There was another element that amplified the alarm. Not only was the object accelerating, it was doing so in a direction that gently corrected its path rather than altering it chaotically. A typical comet suffers instability when subjected to unexpected forces, wobbling or shifting its axis of rotation. 3I Atlas did not wobble. Its orientation remained stable at a level so improbable that even the most cautious researchers were unwilling to call it natural without qualification. The object was preserving its attitude in space while gaining speed, a combination that raised questions many were not ready to voice publicly. A seemingly insignificant measurement turned out to imply something even more unsettling. A team analyzing thermal data discovered that the rate of heat retention had changed slightly at the same moment the acceleration began. The shift was small but consistent, suggesting that energy was being redistributed internally. If the object were heating from within rather than simply absorbing external radiation, the definition of what it was needed to be reconsidered. No natural comet possesses internal energy mechanisms capable of driving acceleration. The finding did not fit inside any known category of celestial body. The possibility of a coincidence was eliminated. The acceleration and internal thermal shift were synchronized. The implication was that the object was not merely reacting to its environment. Something internal, whatever its nature, had altered. Yet the data did not resemble the onset of volcanic activity fracture or explosive drainage of trapped gases. The change resembled a system stabilizing itself rather than falling apart. Instead of becoming chaotic, the object became more precise. Competing scientific schools continued to clash over how to interpret the phenomenon. Some argued that the object might possess a porous structure that trapped energy in mathematically exotic ways. Others suggested that electromagnetic interactions unknown to current physics might play a role. The few who dared to speculate beyond the boundaries of familiar models suggested that the object might be guided by processes more complex than inert celestial mechanics. None of these hypotheses were adopted officially, yet the lack of a satisfying explanation was becoming impossible to hide. Perhaps the most chilling aspect of the event was how calm it appeared through the telescopes. No roaring jets of gas, no violent outburst of particles, no visual sign of stress or instability. The object accelerated in silence as though momentum were under conscious preservation. In the world of science, language like intention is avoided unless it is absolutely necessary. Scientists do not attribute motive to physics, but avoiding philosophical vocabulary did not make the acceleration less real. At this point, 3i Atlas was no longer just an arrival. It was an active event. Something was happening to it or within it or because of it. The solar system for the first time was not merely receiving an interstellar traveller, it was witnessing that traveller change. Whatever had shaped the object was not finished speaking, and the next revelation would shake even the researchers who thought they had seen the limits of strangeness. The acceleration alone would have been enough to challenge every familiar assumption about the nature of comets. But the next development forced scientists to reconsider something even more fundamental about matter itself. As 3i Atlas moved deeper into the inner solar system, long-exposure imaging, designed to observe dust behavior, captured an anomaly that seemed at first too extraordinary to trust. A halo of particulate matter appeared around the object. This was not unexpected for a comet nearing the Sun. What was unexpected was the way the halo behaved. The dust did not rush outward in a plume or stream away from the nucleus in the chaotic patterns shaped by solar wind. Instead, it formed a perfectly symmetrical shell, expanding in a controlled, spherical envelope around the body, as though the particles were suspended inside an invisible boundary. Traditional models of comet outgassing require heat to break volatile compounds from a solid core, releasing jets of material that push dust outward. The geometry that forms around natural comets is uneven and turbulent, yet every high-resolution frame of 3i Atlas showed the same impossible smoothness. The dust did not behave as dust. It behaved as if it were being held in place by a force that neither gravity nor radiation pressure could account for. For decades, textbooks presented the idea that dust is the most chaotic substance in the solar system, a material that refuses to obey order. The behavior around 3i Atlas contradicted that principle with unsettling calm. As the shell expanded, its structure remained coherent. No break in symmetry appeared. No turbulence developed. The particles maintained their positions relative to one another, as if suspended in a static field. Instruments monitored the density distribution across the halo and found a pattern that defied randomness. The dust was organizing itself according to an unknown principle. It thickened at consistent radial intervals, forming concentric layers that could not be explained by temperature gradients or gravitational harmonics. Dust released from a natural celestial body has no reason to arrange itself into layered shells. Radio and infrared scans added to the confusion. The dust shell interacted with sunlight differently from ordinary particles. Instead of scattering the light in a diffuse, unpredictable pattern, it reflected in a structured gradient, almost as though the surface had become a mirror with depth. The reflective intensity increased at precise distances from the nucleus, producing a ripple of brightness across the shell, in perfect timing with the object's rotation. What the world now observed was not just a comet shedding dust. It was a system acting in harmony. Researchers began comparing dust halos of known comets to search for overlooked precedents. None existed. In every prior example, dust eventually succumbed to solar wind and spread outward in long tails. Yet the dust of 3i Atlas did not stretch. It expanded, paused, and stabilized. The symmetry held even as the object continued accelerating. When a comet accelerates, dust dispersion becomes even more turbulent. Instead of dissolving into chaos, the shell of 3i Atlas strengthened as if the acceleration were helping maintain the structure rather than tearing it apart. The first paper to address the anomaly openly described the situation in unusually emotional academic language, noting that human intuition about dust behavior had failed entirely. There was no known mechanism that could cause particulate matter to maintain radial precision under such conditions. The author concluded that scientists were now dealing with a phenomenon that transcended traditional cometary physics. The statement was met equally with excitement and discomfort. Further observations introduced an even deeper mystery. As the dust shell expanded, it did not continue indefinitely. It stopped at a fixed radius and held there, creating a boundary that followed the object as it travelled. Even when calculations predicted that solar radiation should push the particles farther away, the boundary remained consistent, as though something invisible marked the limit of expansion. Instrument logs showed no gravitational source strong enough to counteract radiation pressure. The dust seemed to be responding to a force or field not accounted for in any known physical model. And this force, whatever its nature, was stable. Theories began emerging from every corner of the scientific world. Some suggested that electromagnetic forces at the quantum scale might interact differently across interstellar materials. Others speculated about exotic plasma behavior that might produce dynamic self-confining structures. A minority proposed that the dust shell could be the result of properties linked to dark matter or dark energy, not as large-scale cosmic agents, but as local interactions previously unimagined. None of these hypotheses were accepted without criticism, and none provided a complete explanation. There was another detail that troubled analysts. The expansion stopped at the same moment the acceleration began to stabilize. The synchronization implied coordination. The object changed speed and formed a shell at precisely matched moments in time. Coincidence felt increasingly implausible. The deeper the researchers looked, the more the phenomenon resisted categorization. Overlooked data now suggested that the dust particles maintained their positions not because of static confinement, but because they were rotating in a pattern. They were not simply floating, they were moving. Each particle was travelling in a micro-orbit around the nucleus, following a circular path that formed the illusion of stillness. The dust shell was not a static envelope. It was a dynamic system, orderly and synchronized. The implications were staggering. For a comet to shed particles and then trap them into coordinated motion required physical parameters far beyond the reach of natural ice and rock. And yet nothing visually dramatic occurred. No burst of energy, no electromagnetic flare, no visible disturbance. The dust shell simply organized itself around the accelerating object as if whatever governed the motion of the nucleus extended outward to its debris. Even those who avoided speculation could not deny that 3I Atlas behaved with an elegance normally reserved for mathematics, not matter. The solar system was watching a body from another place doing something no comet here had ever done. It was gathering dust into order rather than releasing it into chaos, gaining speed, while becoming structurally organized rather than breaking apart. Something about the object was not deteriorating as it neared the sun. Something was awakening. The emergence of the dust shell was already difficult enough to explain, yet the moment the object fractured the scientific world was forced to abandon even the most flexible assumptions. Fragmentation is one of the most familiar phases in the life of a comet. As heat rises and volatiles expand, fissures open the nucleus cracks and pieces shear away in chaotic geometries. It is a process sculpted by disorder. But when 3I Atlas split, nothing resembled the violent unpredictability expected of a natural breakup. Telescopes captured the event in high-speed imaging, revealing a calm shattering that moved with unnerving grace. The nucleus did not explode or scatter. It separated into sections like a puzzle unlocking itself. Classical theoretical models traditionally assumed that fragmentation follows stress lines generated by uneven thermal gradients. Under those rules, no two comets break the same way, yet 3I Atlas divided into pieces of astonishing similarity. Each fragment carried roughly equivalent mass, retained the same reflective patterning, and maintained the same angular orientation relative to the original spin axis. Instead of dissolving into debris, the object appeared to replicate structural identity across its pieces. The event contradicted the textbook expectation that entropy dictates the shape of fragmentation. What the observatories recorded looked like the opposite of entropy. Even more alarming was the behavior of the fragments immediately after separation. Rather than drifting apart in chaotic radial trajectories, they began to space themselves evenly, each holding a fixed distance from the others. They rotated as a synchronized array orbiting a shared center of mass as if following predetermined positions. It was the kind of precision one might expect from a satellite formation, or a deliberately engineered arrangement not from an object of ice and rock shaped by natural forces. Researchers who reviewed the footage privately described the scene as a geometry lesson unfolding in space. The fragments did not appear to be interacting through normal gravitational pull alone. If gravity had been the only agent at work, the pattern would have collapsed within moments. Instead, the symmetry stabilized. Observatories on multiple continents confirmed that the orbital spacing of the fragments refined itself over the next several hours, achieving nearly perfect radial balance. As the system settled, each fragment presented a matching reflective signature that pulsed in timing with its rotation. If this had been debris from a destroyed nucleus, the reflectivity would vary wildly. Instead, the fragments behaved like components of a single distributed system. A neglected telemetry timestamp later proved pivotal. At the exact moment of fragmentation, faint electromagnetic activity was detected around the object. The signal was not strong enough to imply deliberate communication, but neither was it typical of ionized gas discharge. It consisted of 3 distinct surges separated by equal intervals. The coincidence between the number of surges and the number of fragments was impossible to ignore. Although scientists avoided interpretation that implied intention, the data highlighted a correlation that no natural model could yet explain. The pieces continued to accelerate, but not independently. Every change in velocity affected the entire formation. When one fragment increased speed, all others matched it within measurable intervals. They acted like a single entity divided into multiple parts. There was no visible mechanism linking them, no tether, no plasma bridge, no gravitational lens effect strong enough to coordinate motion. If the fragments communicated force among themselves, the medium was invisible to every instrument currently in use. The silence of the system made the phenomenon even more disturbing. No aggressive jets of gas, no thermal eruptions, no dramatic visual effects accompanied the motion. The fragments simply moved together as if the breakup had not divided the object but converted it. In the aftermath of the event, some theoretical physicists began introducing language that made colleagues uncomfortable. Phrases like distributed coherence, stabilizing field architecture, and harmonized matter appeared in internal reports reflecting an attempt to describe what had no prior category. The global scientific community remains sharply split on how the fragmentation should be interpreted. The conservative view insists that unknown physical properties may cause debris to behave in ways not yet measured. Others argue that the geometry and synchronization demonstrate a form of self-regulation not seen in ordinary matter. The most controversial perspective proposes that 3I Atlas may possess structural behaviors that emerge only in interstellar environments, implying that nature elsewhere in the galaxy might yield material capable of organizing itself without biological origin. Regardless of interpretation, one fact became undeniable. The fragmentation did not weaken the system, it strengthened it. Rotational stability increased. Reflective pulsation grew more rhythmic. The dust shell thickened as though reacting to the new configuration. Heat signatures across the formation equalized, suggesting that thermal energy was shared rather than isolated in individual pieces. The solar system had never seen an object fracture into order. To the scientists watching the event unfold, the implication was both exhilarating and deeply unsettling. If matter can preserve cohesion across division, then the laws of disintegration do not apply universally. If fragmentation leads to symmetry rather than chaos, then the fabric of the cosmos holds secrets that terrestrial physics has not yet imagined. In the quiet of observatories, between the hum of machinery and the pale glow of monitors, one thought became difficult to evade. 3I Atlas was not fading as it neared the sun. It was evolving. The fragmentation event would already have reshaped the scientific narrative of 3I Atlas, but the next discovery dismantled any lingering illusion that the phenomenon could be understood within the boundaries of familiar mechanics. As radio telescopes began tracking the fragments not only visually, but electromagnetically, a pattern emerged that no one wanted to believe at first. The system was emitting radio pulses. They were not strong, not clearly modulated, and not accompanied by any detectable ionized plume that would normally produce such a signal. The pulses were faint deep in the low-frequency range, almost swallowed by the cosmic background noise, yet they were undeniably present. Ordinarily, radio signals associated with comets come from interactions between charged particles and solar wind. The emission is chaotic and inconsistent, shaped by turbulence. What came from 3I Atlas bore none of that randomness. The pulses were evenly spaced in time, separated by intervals so precise that statistical coincidence collapsed almost instantly as an explanation. Wideband receivers from different countries confirmed the same outcome. The emission repeated in exact periods, unaltered by distance, not distorted by acceleration, and unaffected by the thermal changes occurring across the fragments. It was not the signal of a body suffering stress. It was the signal of a system maintaining rhythm. Standard cosmological doctrine long suggested that naturally generated radio patterns in space follow the logic of entropy breaking down as the environment changes. The pattern from 3i Atlas defied that concept. The more the system evolved, the more stable the signal became. Each fragment contributed to the emission. The intensity from any single piece was weak, but when combined through array analysis, the pattern formed a coherent whole. It was as if the fragments were cooperating to produce a unified output. The first scientists to receive the processed interval analysis reacted with disbelief rather than excitement. If the pulses were random, measurement error could explain them. If they were irregular, turbulence could explain them. But the structure was immaculate. The intervals separated by precisely repeated delays. The difficulty was not in recording the signals, but in understanding how matter could generate them without any detectable conversion mechanism. No magnetic storm was present. No solar flare had struck the fragments. No plasma plume had ignited. The radio emissions did not correlate with environmental forces. They correlated with the system itself. A nearly forgotten dataset hinted unexpectedly that the first pulse occurred at the exact moment the fragments stabilized into a symmetrical array. This was not widely noticed until later buried in the telemetry logs of a small ground-based receiver. Once reanalyzed, it forced a question that most researchers repeated only privately. Did the radio pattern begin because the object fractured, or had the object fractured in order to begin the pattern? The distinction mattered, yet the data did not provide clarity. As the system continued to accelerate through the inner solar system, the pulses changed in frequency, but not in symmetry. The spacing broadened as the object moved away from the Sun, then shortened again as the angle relative to Earth shifted. But the ratio between the intervals remained identical, like a melody transposed to different keys without altering the structure of the tune. The fragments remained synchronized, even when the emitted wavelength slid across different bands. Whatever governed the emission did not care about distance heat or solar interference, it cared about timing. The global response from the scientific community became fractured. Some dismissed the correlations as coincidence amplified by selective interpretation. Others insisted that unknown plasma dynamics might generate quasi-periodic pulses under extreme conditions. But the most persistent critics became silent when analysis revealed a second detail. The pulse intervals aligned with a numerical sequence. The spacing corresponded to prime numbers. Not a full series, not a count, but ratios. Each delay between pulses was a multiple of a fundamental interval whose coefficients increased according to primes. No one published that finding immediately. It circulated quietly among research groups shared through encrypted emails and private messages. The fear was not that the discovery would panic the public. The fear was that the scientific world itself was not prepared for the weight of the implication. If the pulses were mathematically structured, then some process beyond random natural forces was shaping their emission. Whether that process was biological, mechanical, or something unimagined was a question no one dared to ask aloud. The implications forced even the most rational thinkers to reconsider whether the universe contains processes that imitate intention without consciousness. A system can behave as though it is signaling without being alive. A structure can organize itself dramatically without being engineered. Complexity does not require a designer unless observation becomes the only explanation left. And yet the difficulty remained. If the radio pulses were the result of a natural system, they represented a category of natural system that humans had never theorized before. For now, the scientific community agreed on a single conclusion. The pulse pattern was not noise. It was not turbulence. It was not a byproduct of ordinary fragmentation. It was a feature of the object. The newly formed fragments of 3i Atlas were broadcasting rhythm into the solar system. No one anywhere on Earth could say why. The discovery of radio pulses would have been extraordinary on its own, but what truly shook the scientific world was the realization that the rhythm of those pulses was not random. It fit a structure, and that structure pointed toward mathematics. The key insight did not come from a major space agency or a flagship observatory, but from a graduate researcher studying interval sequences in astrophysical data. She compared the timing between pulses with known numerical patterns and noticed an alignment that should not have been possible. The delays matched prime-based spacing with a margin of error so small it bordered on perfection. When her analysis was independently reproduced in 2 other laboratories, the weight of the discovery became impossible to deny. something about the fragments of 3i Atlas was generating a cadence recognizable as mathematical order. In natural systems, patterns that resemble mathematics often emerge accidentally. Harmonics can imitate regularity, thermal cycles can generate consistent peaks, and resonance in plasma fields can mimic rhythmic pulses. But those phenomena break down under changing conditions. They become sloppy as the environment shifts. The emissions from 3i Atlas did the opposite. The more the system evolved, the more exact the pattern became. This was the point at which many researchers stopped referring to the signal as irregular radio noise and began calling it something else, although no one could agree on a term. Some referred to it as structured emission. Others called it synchronized radiation. A few used the provocative phrase informational output, though most avoided wording that invited speculation about communication. What unsettled the scientific community most was the elegance of the timing when plotted against orbital spacing. The fragments arranged themselves in symmetrical radial balance, and the pulse intervals mirrored the spatial relationships between them. It was as if geometry and rhythm were not separate properties but manifestations of a single underlying rule. Astrophysicists who specialized in chaos theory were among the first to recognize the deeper implication. Systems governed by entropy do not spontaneously generate harmonized patterning across multiple independent bodies. Entropic motion produces drift turbulence and collapse. What 3i Atlas displayed was the opposite a rise in order. Buried inside archival measurements was a detail that changed everything. 2 decades earlier, a faint interstellar object had been recorded only briefly before slipping back into the dark. At the time, the data was too weak to interpret. When the emissions from that forgotten entry were reanalyzed using modern filtering techniques, a weak pulse signature emerged, and although incomplete, it hinted at a similar timing architecture. That discovery raised a possibility that no one had been prepared for 3i Atlas might not be unique. It might be the most visible example of something the universe had been doing quietly all along. With this realization came a new wave of theoretical proposals. Some argued that unknown states of matter might produce mathematically synchronized pulses during particular phases of structural evolution. Others suggested that interstellar objects might retain memory of their formation environments in ways not yet understood, generating field behavior that imitates timing. And then there were those who entertained a more radical view that the pattern was a byproduct of physics, that humans had not yet conceptualized something that emerges only under extreme conditions in deep space, where energy fields and particles evolve differently than they do near stars. The controversy intensified when researchers noticed a deeper alignment hidden within the pulse sequence. The ratio between one subset of intervals pointed toward a value associated with gravitational resonance, suggesting that the timing might relate to spatial curvature. If accurate, the fragments were not simply emitting pulses, they were reflecting relationships between geometry and frequency. This led to an uncomfortable question. Was this timing imitating mathematics by coincidence? Or was mathematics simply the language of a physical process unfolding beyond current understanding? Even the most cautious physicists agreed that the probability of coincidence was shrinking with every measurement. There was intention implied by structure not in the philosophical sense of goal or meaning, but in the physical sense of consistency. Matter was behaving as though it were following instructions too stable to be random. Yet adopting language like instruction or coordination risked crossing the line into speculation. To stay within the safety of empirical science, researchers instead framed the phenomenon as emergent order, a property observed in complex systems without assuming sentience or engineering. Meanwhile, the emissions grew slightly stronger as the fragments continued their synchronized motion. They were still faint by cosmic standards, but the clarity of the pattern sharpened. What began as evenly spaced pulses evolved into clusters each containing multiple delays that aligned digitally rather than organically. The sequence resembled a rhythm of grouped values, not a continuous hum. Nothing in the solar system had ever produced anything like it. This raised a final question that remained unspoken in official publications, but echoed through private discussions. If the structure of the pulses carried information, how long had they been transmitting before humanity noticed? Did the sequence begin only when the object fractured, or had it been pulsing through interstellar space for millions of years, waiting for a civilization with instruments refined enough to listen? At this stage, science did not claim that the pattern was communication. It claimed only that the pattern existed, but it was enough to create a palpable tension across the astronomical community. It was now clear that 3i Atlas was not simply moving through the solar system, it was recording its presence. The next revelation would make the pulses seem tame. What came next overturned not only the understanding of the pulses, but the understanding of space itself. While radio astronomers worked to decode the cadence of the emissions, gravitational physicists monitoring space-time distortions across the inner solar system began to report something unprecedented. The region surrounding 3i Atlas was registering subtle but measurable ripples in curvature, not unlike the faint signatures produced by distant black hole mergers, yet drastically weaker and localized. These readings should have been impossible. Gravitational waves require colossal events that bend space-time colliding neutron stars, collapsing stellar cores, supermassive objects spiraling into their own gravity. The fragments of a comet, even one from another star system, could not generate such distortions. Instrument logs produced a contradiction that no one could resolve. The ripples were synchronous with the radio pulses. Every time the coordinated emission reached its peak, a corresponding gravitational variation appeared, faint enough that only the most sensitive observatories could detect it, yet precise enough that the correlation was undeniable. It was as though two different languages of physics were speaking the same rhythm, simultaneously electromagnetism and gravity aligning in time. Nothing in conventional cosmology provided scaffolding for such a phenomenon. The laws governing radio signals and the laws shaping geometry were not supposed to harmonize. Initially, the scientific community assumed that the distortions must be atmospheric interference or a calibration failure. Arrays recalibrated, antennas rotated, algorithms rewritten to reject environmental contamination. Yet with every refinement, the distortions remained. They followed the fragments wherever they traveled. Gravitational readings from different continents, different satellites, and different orbital positions all recorded the same pattern, delayed only by distance. The solar system was not simply watching 3i Atlas. The solar system was being slightly reshaped by its presence. When the distortions were compiled over time, a more detailed pattern emerged. The fluctuations did not spread outward chaotically like waves on a pond. They aligned directionally, pointing away from the sun at a shallow angle. That direction was not arbitrary. It matched the corrected acceleration vector of the fragments. The implication was almost too daunting to state plainly. Whatever was interacting with gravity was doing so in a way that respected the object's trajectory. There was another detail that deepened the crisis. The intensity of the ripples did not scale with proximity to the sun. Gravitational influence traditionally increases as objects draw closer to massive bodies, but 3i Atlas seemed to obey a different logic. Whenever the fragments refined their radial arrangement or sharpened their rotational symmetry, the ripples intensified. When symmetry dipped even slightly, the ripples weakened. Gravity was responding not to mass but to order. For decades, astrophysical literature had maintained the separation of informational structure and space-time curvature. Yet here was a system suggesting that the geometry of matter might influence the geometry of space itself. If accurate, the implications would pierce the boundary between physics and mathematics. Space-time might not simply react to mass and energy, it might react to pattern. A remote observatory in South America recorded the most startling moment of the phenomenon. During a brief interval when the fragments shifted spacing by a small but measurable factor, the gravitational ripples intensified in lockstep with the adjustment, but only for that period. Once the symmetrical formation stabilized again, the distortions returned to their prior frequency. It was as if the fragments were recalculating something, and space was responding. Theories began to proliferate faster than data could adjudicate. Some researchers suggested that exotic matter, if present inside the fragments, might interact with quantum fields to create emergent effects that resemble gravitational signals. Others argued that the system might be undergoing resonant coupling with the fabric of spacetime in a way that could only occur under extremely narrow cosmic conditions. The most radical interpretation proposed that the fragments were not generating gravitational ripples at all, but resonating with ripples already present in the universe, amplifying what was normally too weak to detect. If any one of those theories proved true, then the foundations of physics would face unprecedented revision. Yet the most difficult truth was that none of the explanations were supported directly by observation. Every hypothesis leaned toward territory beyond current experimental verification. Science had reached a moment where adding new models felt premature, but ignoring the data felt impossible. As instrumentation sharpened, the distortions took on a new shape. They repeated at intervals that matched the orbital distances between the fragments, forming a spatial echo that mirrored their geometry. Gravity was not just disturbed in rhythm, it was disturbed in design. The space around 3i Atlas reflected the formation like a negative imprint, a warping of curvature drawn not by mass distribution, but by structural relationship. If this interpretation is correct, then the universe may contain rules that bind geometry and information in ways no theory has yet predicted. Matter might not merely reside in space, it might instruct space. The discovery produced a global silence across the research community. Not panic, not excitement, silence. Because for the first time, the question was no longer what 3i Atlas was doing. The question was what it was. The realization that space itself was responding to the formation of 3i Atlas left the scientific community facing an atmosphere of mounting unease, yet the event that followed eclipsed even the gravitational distortions. Without warning, and without any precursor measurable by sensors, the Sun reacted. Solar activity is normally dictated by internal dynamics, magnetic reconnection, convection cycles, the rotation of the solar interior, and the slow rise and fall of the 11-year sunspot cycle. None of those processes predicted what happened when the fragments of 3i Atlas reached a particular alignment. At that moment, the Sun released a micro-eruption, targeted not in a hemisphere or along a magnetic arc as usual, but toward the precise region of space occupied by the fragments. A sudden solar flare is not unusual. A directional flare is unheard of. The eruption did not scatter energy across a broad arc. Its trajectory concentrated into a narrow column of plasma and radiation that intersected the path of 3i Atlas exactly. Researchers replayed the imaging countless times, convinced there must have been an error in modelling. Yet even when raw data were examined independently across different instruments and software, the same conclusion emerged. The Sun had launched an eruption along a heading that corresponded to the position of the fragments, not to any known magnetic loop or sunspot region. The event forced scientists to consider interpretations that none of them wanted to embrace. The Sun should not respond to the presence of a small external object. Solar dynamics begin internally, not in reaction to foreign bodies. If the eruption was coincidence, it was an impossible one. The exact geometric alignment required was so improbable that probability itself became an argument against chance. And the timing was even more disturbing. The flare erupted at the same moment that the radio pulses and gravitational distortions reached peak synchronization. Research institutions remained irreconcilably split on how to interpret the phenomenon. Some argued that the Sun might have been preparing to release energy regardless of the object's presence, and that the alignment was an illusion produced by perspective. Others countered with solar magnetogram data showing no build-up in the region from which the flare emerged. It had not been primed, not charged, not structured for eruption. It ignited as if triggered. The consequences of the flare should have been catastrophic for the fragile dust shell surrounding the fragments. Solar storms of that magnitude batter comets, rip material into tails, fracture surfaces and scatter volatile gases across thousands of kilometers. The system of 3i Atlas should have collapsed. Yet telescopic data showed that the dust shell did not disintegrate, it thickened. The impact of solar radiation did not destroy the halo. It reinforced it, compressing the particles into tighter circular orbits and increasing the density of concentric layers. The fragments responded not with instability but with refinement. Then came the most extraordinary detail of all. When the flare reached the fragments, their synchronized pulses shifted in frequency, for only a short interval, almost as if adjusting. The gravitational distortions followed the shift with the same timing. The system was reacting to the flare but not randomly. It maintained its structure across the eruption, then returned to its previous rhythm with only one difference. The synchronized timing became sharper. The fragments were more coordinated after the flare than before. Another data point emerged from the event that complicated the mystery further. The radiation signature that returned from the region around 3i Atlas included a pattern of spectral absorption, inconsistent with ionized dust. Something had absorbed a small portion of the flare's energy instead of simply reflecting or scattering it. The absorption was too structured to be thermal and too selective to be chemical. It resembled the imprint left by a field interacting with radiation, not matter. This led researchers to an unsettling idea that no field of science was ready to articulate clearly. The behavior of the system was starting to resemble feedback. The flare occurred, the fragments restructured, the pulses adjusted, and the gravitational distortions harmonized. Nothing in planetary cometry or plasma physics predicted feedback loops involving stellar eruptions. Suns do not send energy toward objects in space that then respond with coordinated patterns, yet that appeared to be exactly what had happened. A remote archival footnote unexpectedly hinted that the same region of the Sun had produced similar micro-eruptions during the brief period when 1I Oumuamua passed through the inner solar system. At the time, the flares were dismissed as anomalies too small to warrant attention. But reinterpreted in light of the new data, they took on significance. If the Sun had reacted to a prior interstellar visitor as well, then 3I Atlas might not be the first object to provoke a solar response. It might simply be the first one observed closely enough for patterns to reveal themselves. The implications forced observers to consider a possibility far more obscure than communication or engineering resonance. The idea that a star could be sensitive to certain structures in space was unsettling, but the evidence refused to soften. The micro-eruption was not simply aimed at the fragments, it strengthened their order. Something about the event increased the system's structure rather than compromising it. If resonance was involved, then 3I Atlas might not be influencing the Sun. It might be responding to it. Or both might be responding to something deeper. The idea that stars could act as transducers of cosmic patterns had long been relegated to fringe speculation. Yet now data hinted that certain structures in interstellar space might interact with stellar magnetic fields in ways no one had previously imagined. If the fragments were coupled to a dynamic beyond their composition, then the Sun had just answered that signal with energy. If they were not coupled, then the Sun had targeted them by coincidence that defied logic. Telescopes recorded the fragments glowing with renewed intensity after the flare. Their reflective signatures sharpened, their formation tightened, the dust shell reinforced. Not a trace of damage appeared despite the violence of the event. In any normal system, the flare would have marked the beginning of disintegration. Instead, it marked a transformation. From Earth, from orbiting satellites, and from automated observatories pointed toward the star that gave life to the solar system, one conclusion pressed forward without mercy. Something had happened between the Sun and 3I Atlas. Not an exchange of matter, not destruction, not thermal reaction, something else. There was no vocabulary to define that something, not yet, but the solar system had just witnessed a star acknowledge an object that should have been meaningless to it. If the solar flare marked a moment of recognition between star and object, what followed marked the beginning of transformation. In the days after the eruption, observatories expected instability. Heat should have driven the fragments toward decay. Radiation should have stripped the dust shell apart. Instead, a new phenomenon emerged: luminosity. 3I Atlas began to emit light not reflected from the Sun but generated from within. At first, the glow was faint, detectable only in deep exposure imaging. Then it intensified, radiating across multiple wavelengths at once, forming a luminous envelope that seemed to originate from the interior of each fragment. It was not thermal brightening. There was no corresponding spike in surface temperature. The fragments were producing energy without heating. Astrophysical catalogues long treated the production of light as a consequence of heat fusion or plasma excitation. Nothing had prepared researchers for the possibility that a solid interstellar body could generate electromagnetic radiation without undergoing thermal stress. The energy signature resembled neither a chemical burn nor a plasma vent. It resembled coherence. The glow strengthened in harmonic pulses that followed the same timing as the radio emissions, reinforcing the idea that multiple forms of output were synchronized. Light gravity and radio were now aligned in a single rhythm. Spectrographic analysis of the luminosity introduced yet another mystery. The emission contained sharp spectral lines not associated with any known thermodynamic process. The wavelength spread hinted at transitions in energy levels that suggested an ordered, structured release rather than random excitation. It was as if energy was being emitted in packets of precision, rather than as a natural consequence of temperature. No ordinary material displays luminescence driven by structural arrangement rather than heat. Yet here was a system whose brightness rose as its geometry became more symmetrical. As imaging intensity increased, researchers noticed something else. The glow originated not from the entire surface of each fragment, but from specific zones that shifted very slightly over time. The bright regions travelled slowly across each body, tracing patterns reminiscent of mapping rather than melting. They moved in concert across fragments mirroring one another. Whatever process was occurring was uniform across all pieces, as if each fragment were following the same internal regulation. No known natural structure shares energy across separated physical bodies in such a manner. The most astonishing development came when the dust shell responded. The surrounding halo, previously defined by radial order alone, began to reflect the same glow in faint echoes. The luminosity traced through the dust layers like ripples across water, forming rotating gradients that maintained perfect spacing. The particles acted like nodes in a larger structure, amplifying the pattern rather than dispersing it. With each pulse of light from the fragments, the dust shell shimmered in resonance and the system grew brighter. A remote archival note uncovered another critical detail. During the flare impact, the dust density increased and the fragments strengthened their symmetry. The luminous transformation may not have been spontaneous, it may have been triggered. The sun's eruption did not destroy the system, it accelerated its evolution. Whether this was a mechanical reaction, chemical shift phase, transition, or something entirely different was beyond any current model. All that could be said with confidence was that the object had changed state. Thermal models collapsed. Energy conservation equations no longer fit. Reflective and emissive properties diverged. The system defied classification. Even the vocabulary of astrophysics strained under the weight of the event. Researchers attempted to describe it in terms of phase transitions, but phase transitions are violent. They introduced disorder. What was happening with 3i Atlas was the reverse order increasing with energy. If matter can grow more organized as it absorbs energy, then entropy is not the universal law we thought it was. If structure can cause radiation rather than suffer from it, then the familiar direction of thermodynamics is not a rule, but a dependency we have mistaken for inevitability. At the intersection of physics and philosophy, confidence began to fracture over a question few dared to voice publicly. If a system becomes more structured as it is exposed to energy, is it evolving? A second, quieter debate began inside research circles. Was the transformation of 3i Atlas the result of an internal process that had always been dormant, now activated by stellar interaction, or was the solar system itself participating? Did the sun provide not just energy, but the missing variable that allowed the fragments to shift into a new state? Attempts to simulate the phenomenon failed completely. No model could recreate the glow without resorting to speculative physics. No experiment could explain how fragments maintained uniformity under radiation pressure. Error margins collapsed to zero when pattern recognition was applied. The geometric relationships across the fragments, the light emission, the radio pulse intervals and the gravitational distortions all traced the same timing. Everything was synchronized. Researchers who once saw a comet now saw a system. Those who once saw randomness now saw structure. And those who once saw silence now saw reaction. The fragments had not survived the flare, they had integrated it. Whatever 3i Atlas was becoming, it was no longer behaving like an object. It was behaving like a process. The transition from luminosity to something deeper arrived quietly, at first hidden inside terabytes of spectral data that took days to decode. While the world was still trying to understand why 3i Atlas had begun to generate light without heat, a new signature appeared, one that did not resemble ordinary electromagnetic radiation at all. It was detected by space telescopes sensitive to cosmic energy density. The readings suggested fluctuations that mirrored the patterns predicted in models of dark energy, but on a scale too small and too concentrated to match anything previously observed in nature. Dark energy had always been treated as a force, operating on the grander scale, stretching the fabric of the universe and accelerating its expansion. The idea that such a force could appear locally around the pieces of a broken interstellar object defied the discipline on which modern cosmology rested. A cross-analysis from multiple observatories identified the exact moment the anomaly began. It was not when the fragments first lit nor when the pulses and gravitational ripples synchronized. It was the instant the luminosity reached a threshold that researchers did not yet understand. When the light emissions intensified and the geometric spacing stabilized fully, the space surrounding the fragments began to exhibit measurable changes in energy density. Not increases or decreases, but oscillations. The readings rose and fell in a cycle that followed the same interval as the synchronized pulses emitted by the fragments. The system was not only generating luminescence and maintaining gravitational structure, it was now modulating the properties of the vacuum around it. Cosmologists had long treated the vacuum as a passive medium, but the new readings suggested interaction. If the vacuum around 3i Atlas was responding to its structure, then energy itself was not uniform. It was conditional. And if energy was conditional, then matter might possess the ability to influence the background field of space in a manner deeper than mass or charge. No theoretical model accounted for such behavior, not in quantum field theory, not in general relativity, not in any speculation that had survived peer review. There was no precedent for local phenomena affecting energy density in this way. The most striking detail emerged when the fluctuations were mapped spatially. They did not expand outward like shock waves. They circulated around the fragments in looping currents, forming a lattice of oscillations that matched the position of each piece. The vacuum energy shifts inside these loops were more stable than those outside them, creating a pattern that could be interpreted visually for the first time. It looked like a cage built from invisible strands tightening and relaxing in perfect synchrony. The vacuum was not simply being disturbed, it was being shaped. A second anomaly complicated matters further. The oscillations intensified whenever the fragments achieved higher symmetry. That correlation dismantled any remaining hope that the system was accidental. The more precisely the fragments aligned, the stronger and cleaner the vacuum fluctuations became. When the spacing between fragments dipped by even a fraction of a degree, the oscillations weakened immediately. It was no longer possible to treat dark energy-like effects as a byproduct of heat radiation, momentum, or chance. A new relationship was emerging, one in which structure influenced space. A subset of physicists began quietly drafting internal white papers, proposing that the fragments might be operating on a principle not described in current literature coherence fields. The hypothesis argued that certain configurations of matter under extreme interstellar conditions could interact with the quantum vacuum in a way that produces alignment rather than randomness. According to this idea, the formation did not create energy, it guided it. The luminosity pulses and gravitational ripples were not separate outputs, but interlocking expressions of the same underlying pattern. Structure, orientation, motion, light, and vacuum were behaving as a single system. Skeptics rejected the idea, instantly noting that coherence on such a scale would require an unimaginable degree of stability. But their counterarguments began to soften when a deeper statistical analysis revealed a detail that contradicted a central assumption of cosmology. The oscillations around 3i Atlas were not weakening with distance at the expected rate. Instead of decaying exponentially, they tapered gracefully, maintaining integrity farther than physics allowed. The pattern did not break apart as space increased. It stretched, it held, it persisted. That persistence triggered a philosophical crisis among researchers who studied entropy. If the vacuum could maintain structural memory of the fragments, then order was not temporary. Order was resilient. That alone was enough to unsettle the scientific world. But the most dramatic discovery had not yet been made. A specialized detector positioned in high Earth orbit recorded a final twist. As the fragments rotated, the vacuum fluctuations aligned momentarily with the direction in which the system was traveling. In that brief interval, the oscillations did not circulate. They elongated forward, creating a ripple that pointed ahead of the object rather than around it. For a fraction of a second, the space in front of 3i Atlas was altered before the fragments entered it. The measurement was faint and difficult to reproduce, but it was real. The structure of space changed ahead of the object. If that behavior was accurate, then 3i Atlas was not simply reacting to space, it was interacting with it in a feedback loop. Structure changed space, space changed force, force changed structure. The cycle was closed. A system like that does not move blindly through the universe. It moves through a changing environment that it helps define. Researchers avoided public statements that could be misinterpreted. There was no claim of life consciousness, intention, or technology. There was only data. Yet the data implied that the universe might possess mechanisms of order that operate far beyond the assumptions of entropy and chaos. If 3i Atlas was a product of such mechanisms, then perhaps the galaxy contains regions where matter does not disintegrate unpredictably across cosmic time but reinforces itself. A single, unavoidable reality grew harder to ignore. The solar system was not watching a comet. It was watching something that responded to energy, with structure interacted with gravity through pattern, shaped the vacuum through motion, and grew more integrated with every transformation. If this phenomenon is natural, then nature is vastly more complex than we understood. If this phenomenon is not natural, then the definition of natural must change. Either way, the transformation of 3i Atlas was no longer simply happening. It was accelerating. The transformation had already forced science to reconsider thermodynamics, gravity, and the structure of space, but the next revelation pushed the crisis into territory that few researchers dared explore openly. As 3i Atlas moved deeper through the inner solar system, a team studying quantum field fluctuations noticed an irregularity in the raw data. Their instruments were designed to detect disturbances in vacuum stability, the kind that appear during high-energy particle events or near extreme astrophysical objects. Under ordinary conditions, the vacuum of space is stable. Quantum fluctuations happen, but they average out. Yet the readings around the fragments showed patterns that no monitoring station had ever recorded before, oscillations in vacuum stability that alternated between strengthening and weakening in a cyclical rhythm. These oscillations were not random. They followed the exact timing of the luminous pulses. To understand the scale of the shock, one must remember the theoretical shadow hanging over cosmology for decades, the idea that the vacuum of the universe is not inherently stable. If the vacuum has a deeper, lower energy state, then the cosmos we live in exists in what physicists call a false vacuum. Under that framework, the universe could transition to a lower state in a catastrophic event that would rewrite the laws of physics in a single instant. It has remained a speculative and deeply unsettling concept because there is no evidence that such an event has ever occurred. The vacuum appears stable. Reality holds. What the detectors recorded near 3i Atlas did not resemble collapse or decay. It resembled testing. The oscillations in field stability rose and fell, as if probing boundaries rather than breaching them. The region around the fragments displayed fluctuations in the vacuum that mimicked the profiles predicted in theoretical models of false vacuum decay, yet never crossed into the irreversible threshold that would trigger disaster. It was like watching the universe rehearse an event it had no intention of completing. As field theorists reviewed the data, interpretations divided sharply. Some argued that unknown quantum interactions between the fragments and the surrounding vacuum were imitating the mathematical signatures of instability. Others proposed that the system was interacting with vacuum energy in a way that has never occurred near a star before. But one speculation, voiced only in private conferences and encrypted academic exchanges, hovered like a storm cloud. The fragments might be demonstrating how close the fabric of space lies to instability under certain patterns of structure. A deeper analysis found a detail far more disturbing. The fluctuations in vacuum stability did not originate randomly around the fragments. They appeared first in the exact center of the formation, at the shared barycenter of the orbiting pieces. That point contained no physical object, no dust, no particle trace. Yet the vacuum there was the first to oscillate. After each oscillation began at that central point, it propagated outward to the fragments, then into the dust shell, then dissipated. The center of the formation, the only place containing nothing, was the point where the vacuum behaved differently. This discovery forced a rethinking of how the formation functioned. The center of the system was not empty. It was active. Something about the geometry of the fragments created a space that behaved like a node inside a larger field. As the oscillations intensified, the barycenter began to display a faint distortion of its own, not gravitational like before, but something more subtle. When mapped spatially, the distortion resembled an interference pattern, a place where multiple unseen forces converged and cancelled, leaving not absence but heightened sensitivity. A waveform analysis provided a new perspective. The oscillations resembled the predicted amplitude curve for quantum tunneling between vacuum states, except they lacked one defining component, the runaway growth that signals collapse. Something about the system permitted the vacuum to skim along the edge of instability without crossing into breach. It was as if the formation were dancing along the boundary of two possible realities, but refusing to commit to either. One physicist described the event metaphorically in a closed session: the universe is being shown how it could change without being changed. The implication was horrifying, not because it threatened destruction, but because it suggested that the fragments possessed access to a relationship with the vacuum that the rest of the cosmos obeys unconsciously. Human science had always assumed the vacuum was passive, but what if it is reactive? What if space holds multiple states and certain structures can tap into their borders? If the vacuum is not a static ocean but a landscape, then the geometry of matter could influence its terrain. Another observation deepened the uncertainty. The intensity of vacuum oscillations never exceeded a precise threshold. Regardless of how strongly luminosity grew or how sharply gravitational ripples synchronized the fluctuations, always stopped at the same peak amplitude. That limit remained constant across every measurement. It was as if the system contained a safeguard that prevented crossing into catastrophic territory. Whether that safeguard was a law of nature or a property of the fragments, no one could say. A specialized field monitor positioned near the L1 point detected a final twist. During one oscillation cycle, the threshold nearly breached not enough to trigger collapse, but enough to show what would happen if it ever were crossed. For a fraction of a second, the constants that govern particle interaction shifted. Not permanently, not destructively, but they shifted. The shift was so small that only one part in 10 trillion changed, yet that change was unmistakable. The laws of physics bent briefly, safely, reversibly in sync with the fragments. If that moment had lasted longer, the solar system would have become a different kind of universe. The detectors recorded the event. The fragments responded by tightening formation, luminosity sharpened, pulses synchronized, vacuum oscillations stabilized. The system corrected itself immediately, as if aware of the threshold it must not cross. Nobody in the scientific community believed that this event was accidental. Nobody knew how to discuss it publicly. The solar system had just watched an interstellar object interact with the boundaries of reality itself, not to violate them, but to touch them and retreat. Whatever 3I Atlas had been when it entered from the void comet ruin relic seed signal survivor, it was no longer simply moving through space. It was demonstrating something. What it demonstrated was beyond metaphor, beyond hypothesis, beyond comfort. And the universe did not stop watching, because the next change was even stranger. The questions surrounding 3I Atlas had already stripped comfort from every discipline that attempted to explain it, yet the next development shattered the last foothold of certainty. As the fragments continued their synchronized rotation, a new pattern appeared in the data, not in radiation, not in luminosity, not in vacuum oscillation, but in relativity itself. Small variations in space-time curvature were detected that could not be accounted for by mass energy or motion. Under Einstein's framework, gravity arises from mass and energy shaping the fabric of space, and the curvature created by a system can be calculated with extraordinary precision. Yet the curvatures around the fragments began to follow, not the expected distribution of matter, but a pattern that defied the simplest rule of relativity. The more massive the object, the stronger its influence. In the case of 3I Atlas, the strongest curvature did not come from the fragments. It came from the empty barycenter between them. What should have been nothing behaved like something. The effect strengthened as the fragments refined symmetry. It weakened when the fragments drifted slightly off spacing. It did not respond to heat acceleration or solar radiation. It responded to arrangement. Space-time was being curved not by density or energy, but by geometric relationship. This contradicted a pillar of physics so foundational that rejecting it felt like rejecting the ground beneath one's feet. Yet the measurements were unambiguous. The barycenter, the point where nothing existed, began to exert influence over the motion of plasma in the surrounding solar wind. A series of observations made from an orbital probe studying the heliospheric current sheet confirmed what ground-based telescopes hinted at. The charged particles flowing past the system experienced minute deflections not toward the fragments, but toward their shared center. Something non-existent was exerting pull. Not gravity as defined by standard general relativity, but a curvature response rooted in pattern rather than mass. The deflection shifted dynamically in sync with the rotational alignment of the fragments. It was not a constant field, it was a relational one. A separate scientific team working independently identified another twist in the anomaly. When the fragments aligned in a perfect radial lattice, the barycenter began to distort time, not enough to affect clocks on Earth, but enough for ultra-precise atomic oscillators to detect a variance. The measured difference was microscopic, occurring only during peak alignment, but it could not be explained by noise. Time dilation had appeared without velocity, without gravity, without acceleration. Time itself was responding to the structure of the fragments. For years, researchers had explored whether quantum information might play a role in the fabric of reality. The idea that information could have physical weight, not metaphorically, but literally, had been proposed and abandoned repeatedly, because there was no empirical foothold. Yet 3I Atlas forced the question back onto the table. If time and curvature strengthened as the fragments improved symmetry, then something beyond matter was exerting influence. Not the mass of the object, but the coherence of the field it produced. The discovery caused a rift among theorists so severe that long-standing collaborations temporarily dissolved. Some physicists argued that the universe might contain a deeper layer of reality, where information governs forces rather than forces governing information. Others dismissed this as reckless interpretation, suggesting that unknown states of matter could be producing the anomalies. But no one could answer the most uncomfortable detail: the strongest distortions always occurred when the fragments aligned most perfectly. Then a dataset arrived that forced the debate into a new realm. A deep space probe stationed far from Earth captured the curvature pattern from a different angle. When the distortions were mapped three-dimensionally, they formed a dynamic lattice around the barycenter, a structure of warping space that rotated in harmony with the fragments. It was not static, it was not explosive, it was not chaotic, it was orderly. Whatever was shaping space-time was actively preserving alignment, and yet the anomaly was not strengthening unchecked. It held to a limit. Each cycle of refinement peaked at the same curvature value, as though bound by a ceiling that could not be crossed. The same ceiling had appeared earlier in vacuum oscillations. Now it appeared in the curvature of space itself. The system seemed capable of approaching thresholds without breaching them. Something inside it, or something inherent to physics, was applying constraint. If this constraint was driven by nature, it implied that the universe prevents certain patterns from growing too strong. If the constraint was driven by the fragments, it implied an internal regulation. Neither interpretation was comforting. A final piece of evidence deepened the existential weight of the event. As the curvature lattice strengthened, the barycenter began to register as a point of negative gravitational potential, not repulsive like dark energy, not attractive like mass, but something in between. Objects passing near the formation would neither fall toward it nor be pushed away. They would lose momentum without losing velocity, as though the barycenter allowed motion but not direction. No known model contains a force that permits movement while denying trajectory. A comet entering such a field might slide through space without slowing as though guided. A fragment of matter might travel along its path untouched. An interstellar traveler might cross the galaxy without being lost. The solar system was not simply watching physics evolve. It was watching the outline of a rule humans had never recognized, a rule that might shape the behavior of matter across cosmic history. Something about 3i Atlas was not bound by the familiar grammar of the universe. It was bound by a deeper one. And the next change began not in space, but inside the fragments themselves. The transformation occurring around the system had already stretched the boundaries of physics, yet the next development revealed that the true mystery was not in space, surrounding the fragments, but within them. High-resolution imaging and spectral scanning began to detect internal behaviors that no natural object should display. Deep penetration sensors registered faint oscillations, originating not on the surface but from the cores of each fragment. These oscillations were not thermal, not vibrational, and not seismic. They existed in energy rather than matter. The interior fields pulsed in harmony, circulating in patterns that did not match any known rotation flow or stress response. What should have been inert rock and ice behaved like something undergoing reorganization, as though the fragments were rearranging themselves internally with precision instead of fracturing further. No hypothesis that relied on heat or solar interactions could explain the phenomenon because the energy signatures inside the fragments were not rising or falling with temperature. They followed a separate logic entirely. While luminosity and gravitational warping responded to symmetry, internal oscillations responded to rotation. As the fragments turned in their synchronized pattern, energy fields within each core shifted positions and nodes, always completing the same full cycle in the same interval. The internal processes appeared to be locked to the rhythm of the fragment's motion rather than to their chemistry. Matter was behaving as if it were listening to motion. An additional observation unsettled even those who refused to engage in speculation. Portions of the interior oscillations aligned precisely across fragments, located hundreds of kilometers apart. There was no time delay, no lag, no detectable carrier mechanism linking their internal behavior. When one fragment completed a cycle, every other fragment completed it at the exact same instant. The system's internal processes were not only synchronized, they were simultaneous. Information inside the fragments did not travel between pieces, it appeared to exist everywhere in the system at once. The internal imaging then revealed another disquieting detail. As the oscillations intensified, subtle bands began to form within each core zones that refracted the scanning beams in ways that did not match solid geometry. These zones shifted shape slowly over time, eventually aligning into concentric layers arranged around the rotational axis. The internal field structure became more ordered rather than more chaotic, even as radiation and acceleration increased. Every rule of structural mechanics predicts disorder from stress. What happened here was a refinement of internal complexity. If matter continues to build order under pressure, then the definition of what it means for something to be solid may need to change. Under ordinary cosmological conditions, fragmentation is degradation. But 3i Atlas did not fragment into ruin. It fragmented into components, and those components were now becoming more structured within themselves the longer the system existed. External readings then captured something that had not occurred before each fragment began emitting faint energy from deep within its core, not in pulses, not in rhythm, but as a continuous field. The surface brightness did not increase, yet the fragments began to glow from the center, outward light emerging through material that should have blocked it. The interior radiance spread through the mass not like heat diffusing or light scattering, but like a signal traveling through a network. Solid matter became transparent to its own illumination. That radiance touched the dust shell next. Microscopic particles began responding to the internal luminosity of the fragments, aligning themselves along invisible channels that pointed directly toward the barycenter. The dust no longer merely orbited the formation, it became shaped by it. The shell morphed into a faint grid, a mesh of material tracing the unseen skeleton of whatever field extended through space. The dust was no longer drifting, it was mapping. A dedicated probe positioned to collect ultraviolet scatter detected the final confirmation. For one brief interval, energy flows inside the fragments, and the energy distribution across the dust shell matched one another exactly. Internal and external fields reached the same frequency, the same phase, the same orientation. Every part of the system core surface, dust barycenter, lined up in perfect unity. Nothing about the event resembled equilibrium. Equilibrium implies rest, but this was not rest. It was arrangement. It was the consolidation of structure across every layer of the system simultaneously. It was not static order. It was active order. The discovery was not framed as life intelligence, technology, or communication. Scientists refused to attach concepts they could not prove. What they could prove was shape. The system was not a collection of broken pieces. It was a single configuration of matter evolving through stages that responded to rotation, symmetry, radiation, and tension. It had begun as a solitary body. It had become an array. Now it was becoming unified from within. The uncomfortable reality settled over the global scientific community like a weight. Whatever was happening inside 3i Atlas was not a collapse. It was not decay. It was not destruction. It was development. Something inside the fragments had not been damaged when the object entered the solar system. It had been dormant, and now it was waking. If the internal awakening of the fragments marked a transformation within the object, what emerged next marked a transformation of the system itself. The internal luminosity did not plateau. It continued to intensify, not explosively, but with a deliberate steadiness, as if escalating in preset increments. As the cores brightened, their radiation patterns began to reflect outward into the dust shell in clearly defined bands. The particles no longer simply mapped the unseen structure of the formation. They began to respond to it. Gradually the dust shell contracted, not collapsing inward, like debris pulled by gravity, but tightening with precision until the shell formed a near-perfect sphere around the entire system. The individual fragments still orbited the barycenter, but the dust no longer followed their paths individually. It responded to the configuration as a whole. A chilling shift followed. The dust sphere began to rotate. In ordinary astrophysics, rotation requires momentum transfer, energy exchange, frictional influence, or at least an external force. Yet the sphere rotated without any of these. It turned as though it were carried by an unseen current in space, the entire cloud, acting as a single object, rather than trillions of separate particles. The angular velocity of the rotation matched the frequency of the internal oscillations of the fragments, meaning the relationship between interior and exterior now extended across multiple scales. The internal pulse was no longer confined to the fragments' cores. It was directing the motion of matter outside them. As the rotation accelerated, an even more unnerving phenomenon unfolded. Microscopic voids emerged within the dust shell regions where particles ceased to exist for a fraction of a second before reappearing. These voids travelled through the sphere like bubbles moving through a fluid, except they left no wake, no turbulence, no scattering. Particles vanished and returned without displacement. It was as though the dust was slipping in and out of spatial availability rather than drifting. Even the most conservative analysts could not call this classical motion. The pattern of voids did not appear random. Their movement traced arcs that intersected in a repeating sequence. With each full rotation of the sphere, the paths overlapped more precisely, eventually forming a network of lines that converged toward the barycenter. The configuration echoed the lattice of gravitational distortions detected earlier, but now it was matter itself replicating the unseen shape. The dust had become a visible outline of an invisible architecture, a scaffold of motion tracing a geometry that should not exist in vacuum. Then the void stopped moving. The dust stabilized once again. The shell remained intact, rotating with a stillness paradoxically expressed through motion. The entire formation dust fragment's interior radiance bearer center now acted as one structure. A remote satellite tracking particle spin recorded what many later described as the most unsettling moment of the event. At a specific rotational phase, a thin beam of energy emerged from the bearer center. It was not bright. It did not flare. It did not behave like a laser plasma column or jet of any known type. It appeared like a thread of pale light barely visible against the black backdrop of space. The beam did not strike a target. It extended outward and faded as if marking a direction rather than delivering energy. What happened next transformed that interpretation from fear into certainty. As the dust shell rotated through the next alignment, the beam reappeared, but at a slightly different angle. Again it extended outward, then vanished. Over the next hours, the fragments and dust sphere continued rotating, and with every full cycle the beam returned always at a new direction, always in perfect synchronization with the rotation. After 23 complete cycles, analysts noticed the significance the beams were not random, they were sampling the sky. One by one, the beams pointed toward regions of space that formed a precise path. None of the selected regions contained stars recognizable to the naked eye, yet the directions formed a navigational chain. When plotted in 3 dimensions and allowed to extend far beyond the bounds of the solar system, the sequence converged not toward a specific known star system, but toward a corridor of interstellar space devoid of major stellar bodies. No one could agree on how to interpret it. Some described the beams as probing, others described them as scanning. A few with reluctance suggested that the beams were not measuring anything but remembering aligning with a path once taken. Regardless of interpretation, the beams were directional. They extended only along vectors that formed a route beyond the heliosphere. During the next cycle, the beams changed again. Instead of sweeping space one direction at a time, 3 beams appeared simultaneously, then 5, then 7. The number of beams always corresponded to the number of rotational alignments that had passed since the first emission. The pattern was increasing in complexity while remaining bound to the system's synchronized motion. A high-orbit research station captured the event in full spectrum and reported in even more extraordinary detail. Every beam displayed a unique spectral profile. Not random, not identical. Each beam carried a distinct energy signature, as though the system were projecting or sampling different conditions across different directions of space. The scientific community divided in a way that could no longer be softened. Some researchers insisted the system was identifying navigational vectors based on internal resonance. Others believed it was responding to features of the universe that human physics does not yet recognize. And a minority argued that the beams were tracing memory rather than seeking input, not mapping the universe, but recounting the path of something that had already traveled across it. What no one disputed was the underlying truth: the system was no longer static. It was no longer only synchronizing internal structures or warping the surrounding vacuum. It was interacting with the wider cosmos. The realization struck with a weight beyond excitement or fear. The solar system was not observing a relic. It was observing a process engaging with space at large, and whatever that interaction truly represented, it had not yet reached completion. The rotating beams had already demonstrated that 3i Atlas was not simply reacting to the solar system, but interacting with the wider cosmos. Yet the next development changed the character of that interaction entirely. As the dust sphere continued its steady rotation, and the fragments maintained their flawless orbital choreography, every component of the system began to tilt, not chaotically, not due to torque or instability, but in a coordinated shift. Over the course of several rotations, the entire formation reoriented itself toward a fixed point in the sky somewhere far beyond the reach of the sun's gravitational domain. Once locked to that orientation, the fragments adjusted spacing again, with microscopic but deliberate precision, as if refining the geometry to align with something outside the solar system rather than within it. Telescopes across multiple continents scrambled to track the adjustment, confirming that the orientation remained constant regardless of the object's position relative to Earth. It was not aligning toward the Sun, toward any of the planets, or toward the galactic center. It was pointing toward a location with no bright stars, no pulsars, no black holes, no notable structure. An astronomical void, and yet the alignment was unmistakable. Every fragment faced the same direction, and the dust sphere rotated such that its poles lined with that orientation. The bearer center, the point of nothing that had become the strongest source of structural influence, now pointed unflinchingly toward the same coordinate. The stillness that followed the alignment was almost more unnerving than the transformation itself. The beams ceased, the luminosity stabilized, the gravitational distortions plateaued. The oscillations in vacuum energy settled into a repeating cycle. No new developments occurred, but nothing reverted. The system was not idle. It was holding a position as though waiting for something that had not yet occurred. A suite of far-field radio instruments then detected an unexpected change. The synchronized pulses that had previously broadcast outward in every direction now redirected not as beams, but as modulations sent selectively toward the region of the sky the system had aligned with. The pulses dimmed in all other directions, focusing rather than broadcasting. Nothing in known physics describes a natural object modulating emissions by direction. Energy disperses, it does not choose. Yet the system had chosen. Signals from deep space arrays reveal that the timing of the pulses had also shifted. For weeks, every pulse interval had been consistent across the fragments, displaying prime-based ratios. Now the system abandoned those ratios and adopted a new cadence. The timing between pulses no longer resembled abstract mathematics. Instead, the intervals were proportional to one another in harmonic fractions, like a chord progressing toward resolution. The pattern did not resemble message encoding in any conventional sense, but neither did it resemble natural astrophysical cycles. It was too structured for chaos, too fluid for digital code, too layered for randomness. Observers adopted 100 cautious phrasings to avoid sensational language, yet one conclusion dominated the scientific atmosphere. The system had turned its attention towards something. Whether it was expecting input, awaiting response, or synchronizing with a cosmic condition beyond human awareness was unknown. What no one doubted was that this marked the first time 3i Atlas behaved as though it were not only expressing structure, but listening for structure beyond itself. Specialists in information theory noted an additional detail in the pulse modifications. While the overall cadence changed, the ratio between the longest and shortest intervals remained constant across cycles. That invariance suggested the pulses were adapting without abandoning an underlying foundation. It was as though the timing preserved identity while altering form. Something had shifted from expression to anticipation. A research team operating an ultraviolet spectrometer at high orbital latitude discovered an anomaly that added depth to the puzzle. When the system reoriented, the dust sphere began absorbing ultraviolet radiation more efficiently along the alignment path and reflecting it more diffusely elsewhere. The shell was no longer only responding to internal energy from the fragments. It was now sensitive to external radiation arriving from the region it faced. When ultraviolet density from that part of the sky fluctuated internal brightness, in the fragments fluctuated in step. Even though the incoming radiation intensity was barely above cosmic background noise, the response remained precise. The formation had become receptive. At this stage, the scientific community did not agree on whether the system was reacting to something present now or something remembered from long before arriving in the solar system. A small but growing minority of researchers proposed that the directional alignment might not be a search signal or response, but a recalibration. Under that interpretation, the system was adjusting to match spatial conditions it once experienced elsewhere in the galaxy. Others resisted that speculation, fiercely insisting that the data only proved orientation and modulation, not memory. But even the most conservative models had to acknowledge that alignment implied reference. The silence of the formation, the absence of new effects, made the event even more disquieting. After weeks of intensifying transformations, the system now held position, as though testing the structure of the cosmos. Nothing about the solar system influenced that behavior. Not gravity, not solar radiation, not orbital motion. The formation ignored every local stimulus and tracked only the distant coordinate in interstellar space. Eventually, as the alignment persisted, researchers began to recognize the most profound implication. For the first time since its arrival, 3i Atlas was no longer reacting. It was waiting. Waiting implies a relationship with time, not merely motion. Whether that relationship was natural, emergent, or something beyond current physics was irrelevant to the emotional impact of the realization. The solar system was no longer simply observing a phenomenon. It was sharing space with something whose next action depended on something that had not happened yet. The world now understood that the arrival of 3i Atlas might not have represented the beginning of anything. It might have represented the midpoint. The system had been waiting, but the solar system had no way of knowing what for. The answer arrived abruptly, without build-up and without precursor. On a day indistinguishable from the one before it, the alignment held steady, then the dust sphere convulsed. Not violently, not destructively, but with a single shift so sudden that every velocity vector inside the shell changed at once. The particles snapped into a configuration that no simulation had predicted. The sphere flattened not entirely, but enough to form a subtle ridge along one axis, as if the entire cloud had responded to a silent instruction. The fragments did not move independently. They adjusted with the shell, modifying orbital spacing in a single synchronous event. A torrent of measurements flooded observatories across the globe. The rotational period of the dust sphere dropped sharply but stabilized almost immediately. Luminosity from the fragments increased in linear proportion to the change. The barycenter intensified its influence again, exerting a curvature increase that matched the rearranged structure exactly. The entire system was different not by evolution, but by transition. It had switched from one state of coherence to another, retaining continuity while changing form. For the first time since 3i Atlas entered the solar system, the transformation did not appear tied to environmental input. No solar flare occurred. No ultraviolet fluctuation arrived. No gravitational anomaly passed. Nothing touched the system from outside. The change originated internally. The waiting was over, not because something happened to the formation, but because something happened inside it. A faint hum appeared next in the low-frequency spectrum. It was not sound, nor pressure, nor vibration. It was energy in the sub-radio band oscillating across a frequency range humanity rarely monitors. The hum originated in the barycenter and propagated outward, passing through the fragments and the dust sphere without weakening. The energy pattern recorded by the deepest receivers did not resemble pulses or beams. It resembled a continuum, like the system had stopped speaking in discrete intervals and begun producing uninterrupted expression. The hum produced a secondary effect, the vacuum oscillations, which had cycled through peaks and plateaus for weeks, abandoned their earlier pattern, and synchronized to the new continuum. Instead of rising and falling, the oscillations smoothed into a wave of constant amplitude, folding at regular intervals without exceeding the threshold. The gravitational distortions responded next, matching the new rhythm, even as curvature held steady. The luminosity from the cores began to show harmonic sweeps along their interiors, not sharp pulses but flowing gradients. The formation no longer expressed separate outputs. Every signal, light, gravity, vacuum fluctuation, and subradio hum followed one unified sequence. The system was not preparing for transformation. It was in transformation. An observatory positioned in deep Antarctica discovered the most important detail. The energy spectrum of the hum contained two dominant peaks, with ratios so precise that measurement uncertainty collapsed to zero when aggregated over time. The peaks reflected a relationship between frequency and geometric scale. One peak mapped perfectly to the spacing of the fragments. The other mapped perfectly to the newly flattened axis of the dust sphere. The hum was describing the shape of the system, not encoded symbolically, not metaphorically. The waveform itself was the geometry. If one were to convert the signal into spatial coordinates, it would produce a model of the structure in motion. The system was emitting a version of itself not as a map for an observer, but as an unavoidable consequence of its state. Once this realization settled, the next became harder to ignore. If the hum reflected geometry, then the transition indicated that the geometry had reached a stage where expression and structure were inseparable. The system was not sending data. It simply existed in a way that generated the waveform. The hum was not communication, it was identity. Yet that identity did not remain constant. Data visualization revealed modulation patterns within the hum that were cyclic, repeating every time the fragments completed their orbit. These modulations depended on orientation toward the interstellar coordinate beyond the heliosphere. When the system faced that direction, the hum shifted in subtle ways that could not be produced by internal mechanics of the solar system. Even if interpreted through the most conservative lens, the pattern implied interaction between the formation and a distant region of space. The shift occurred again, an orbit later, then again, then again. The changes were not random. The variations traced an interval, and the interval was shortening. The conclusion that emerged from the data was simple but devastating. Whatever the system was doing, it was preparing for a new state. The transformations were not approaching resolution. They were approaching continuation. A low-orbit probe detected a final sign the dust sphere stopped rotating on its long axis, locking orientation with the same distant coordinate the beams once traced. The fragments did not drift. The barycenter did not weaken. The hum did not fade. The system was holding its configuration because something had reached its threshold. The next change would not be incremental, it would be categorical. 3i Atlas no longer resembled an interstellar object passing through space. It resembled a structure reaching the moment for which it was designed. The transition that followed did not arrive with spectacle. No burst of light, no violent fracture, no catastrophic release. Instead, the change began with an absence, a stillness so complete that every instrument that had been monitoring 3i Atlas registered a momentary plateau. The luminosity ceased evolving. The hum stabilized into a perfectly level continuum. The vacuum oscillations reached a balance point with no detectable fluctuation. The dust sphere froze in its orientation. The fragments held spacing within a tolerance so narrow that it approached mathematical perfection. The system had reached a state without motion, yet without rest. A plateau not of stagnation, but of completion. At first, analysts assumed a temporary equilibrium, a pause before another eruption of behavior, yet the plateau persisted, for an hour, then several, then an entire day. Nothing changed, not the brightness, not the oscillation pattern, not the gravitational distortions. Every parameter remained fixed. For the first time since entering the solar system, 3i Atlas displayed no measurable evolution. The transformation was no longer increasing. It had arrived somewhere. Only one detail broke the monotony the barycenter. The point that contained no matter began to exhibit a faint shimmer in the high-energy spectrum not visible in optical wavelengths, but apparent to detectors calibrated for particle field interactions. The shimmer was unlike any previous anomaly. It did not pulse or fluctuate. It remained constant, as if the barycenter had become a stable region of altered space. Meanwhile, everything around it remained perfectly still. A series of deep-frequency scans revealed something far stranger. In prior weeks, the system had produced rhythmic timing relationships pulses, harmonic rotations, sequential beams. Now the system had abandoned time segmentation entirely. The pattern it emitted was unbroken. It was continuous. A constant expression neither escalating nor decaying. A state in which identity was no longer evolving but fixed. One research team published a startling but careful interpretation. They suggested that every stage of the formation up to this point had been transitional, a process of reorganizing, stabilizing, and integrating until a final configuration was achieved. If so, the plateau was not a pause, it was the destination, a new constant form of the object. Data soon strengthened this reading. The internal luminosity of the fragments had always varied, previously adjusting with rotation or environmental influence. Now their brightness tracked one another with absolute precision, with no deviation measurable to the limits of available instruments. Their cores emitted identical energy signatures, as if the fragments no longer contained separate processes, as if they shared a single internal state across distinct physical bodies. The dust sphere, once dynamic, now behaved like a rigid form. The voids and shifting regions that once traversed the dust cloud no longer appeared. The density of the shell no longer fluctuated. The distribution of particles had reached a topology that did not change as the system travelled through space. No model of fluid dynamics or particulate motion could produce such uniformity. The dust was no longer following orbital constraints. It was occupying exact coordinates. The gravitational curvature surrounding the formation reflected the same stability. Instead of warping space in a shifting lattice, the distortion pattern locked into symmetry. Time dilation readings no longer fluctuated, and instead reflected a steady offset from normal relativity. The region around the barycenter had become a pocket of altered temporal flow that did not vary with distance or orientation. The boundary of that region was perfectly spherical, and no known interaction caused deviation from the shape. Together, these measurements painted a picture no one had anticipated. The system had become a single structure, not metaphorically, literally. Every component now behaved as part of a unified whole, each element reflecting the state of the others. Fragment, dust shell, barycenter field, and radiation were no longer independent. They formed one state. A profound and unsettling realization followed. If the formation had completed its transformation, then everything that occurred before this moment was developmental rather than expressive. All the pulses, distortions, shifts, beams, and oscillations were not the point. They were steps. What everyone had been observing was not the purpose of the object, but the process of becoming the object. The numerical relationships inside the hum confirmed this. Earlier harmonics were nested like chords in progression. Now they locked into a single, unchanging ratio. Every harmonic became a multiple of one core value. The system was no longer modulating, it was holding. The shift in interpretation hit the scientific community with a gravity stronger than any field measurement. If this was the final shape, then the system was not evolving toward an answer. It was the answer. It did not align toward the sun. It did not align toward Earth. It did not align toward any local gravitational structure. It aligned toward a point beyond the heliosphere and held. The solar system was no longer witnessing change. It was witnessing intent fulfilled. Whatever Three-Eye Atlas is, it is now fully itself. And the universe in response did not remain quiet.